Hello everyone, in this video we are going to build a function that generates spiral matrices. So first of all I want to show you what the function does so we are on the same page. Then we are going to write the function and finally we are going to break down the function. So let's start. I generate this matrix. This is a square matrix, 3 rows, 3 columns and is filled up with zeros. Now, the function here that I named spiral underscore matrix, you can see that it's already here in my environment, takes two arguments. One is the matrix, this M object here, and the other one is an initial value. In this case, we set the initial value equal to 1. When we run this, as you can see, the function start from the initial value 1, then add 1 unit, so 1, 2, 3. And then 3, 4, 5, 6, 7, 8, 9 in a spiral order. Let's see another example, a 4 by 4. And as you can see, from 1, we are going to 16. 5 by 5. From 1, as you can see, in a spiral order, we are going to 25. 6 by 6. From 1, and in a spiral order, to 36. So now, one point to take note. We know in advance what is the maximum number that will be filled in the matrix if we start from 1. This is, in fact, this is a 6 by 6 and the maximum value is 36. Before we work with a 5 by 5 and the maximum value was 25. 4 by 4, the maximum value 16. I say this because this is one of the elements we will use to set as condition stop the loop. But I want to show another point here. This is a 7 by 7 matrix. But as you can see now, we start from 3. If we started from 1, the maximum value would be 49 because it's 7 by 7, 49. But now we're starting from 3. So we are starting from 2 units to the right. We are moving 2 units to the right. So 49, we have to add 2 units, 50, 51. And this is another point that we will use to set the condition to stop the loop inside the function. So now let's see the function. First of all, we decide a name. In this case, I set as name spiral underscore matrix, assignment operator, and the keyword function. And as I said, this function takes two arguments, M and IV. M is a square matrix, and IV is an initial value. So at the beginning, the function does a check. Check is if the matrix is square. So we're checking that the number of rows of the matrix, if it's different from the number of columns of the matrix, this means that this is not square. So the function here will stop, and this error message will be printed. The matrix must be square. So if the matrix is square, the function continues here. The first thing here is set initial values. As you can see, the IV, the initial value that we decided, will be set to the first row, first column of the matrix. Then there are these I underscore start, J underscore start, I underscore end, J underscore end, start and end. In this count 1, count 2, these are all elements to control for the number of rows and columns. Specifically, this count 1 and count 2, count 1 is used in the loop 2 and loop 4 to control for the number of rows, and count do is used in the loop 3. But we will talk in more details when we break down the function. After, we have to set the condition to be fulfilled to stop the loop. As I said at the beginning, we know in advance what will be the maximum number be filled in the matrix. That will be here, given by the square of the number of rows of the matrix. But this works if the initial value is 1. If the initial value is different from 1, we have to make an adjustment. Basically, we have to add this one, IV minus 1. If IV is 1, 1 minus 1 is 0. So basically, the maximum value will be this. If IV is different, for example, if IV is in the previous case is 3, 3 minus 1 is 2, and before the matrix was 7 by 7, so 49 plus 3 minus 2, so plus 2, 51. Let me show you again. As you can see, we stopped at 51. So we know the maximum value. But this means that we also know the sequence. And this is the sequence from IV to S max. But now this is another point. We know the sequence, and consequently, we know the sum of all the elements in the sequence. But we have to make this adjustment here. We have to check for the absolute value. And this because we can also supply a negative initial value. We'll see this again in more details when we break down the function. So basically here, this SV is given by the sum of the absolute value of the sequence that goes from IV, the initial value, to the largest number that is given by this. Then what we have to check? We have to check that Sm that is given by the sum of the absolute value of the entries of the matrix is equal to Sv. If Sm is equal to Sv, the loop stops. Okay, so until now we just set the condition and the initial values, but we are outside the loop. The loop starts here, and we have an external loop that is a while loop. Let me show you. The while loop starts from here and ends here. Now, the condition says that this while loop continues to run as long as Sm is less than Sv. So, as long as Sm is less than Sv, everything that's inside will continue to run. And what is inside here? We have four for loops. Why 4? Because we have to move in 4 directions. The first direction is from left to right. The second loop is from top to bottom. The third loop is from right to left. And the fourth loop is from bottom to top. And this will continue as long as the sum of these numbers in the matrix is less than SV. Let's see in a little bit more detail. This is the first loop. For J in this sequence is initially given by these values here. So in this case, I set an if condition, but I will explain this later. So now, what this line of code says. In this case, notice that I star is fixed. Initially, is this value here, 1. This means that the row is fixed, and what is moving is the column. So basically, we are working on the first row. What is moving is the column here. And basically, j plus 1 basically is equal to, so this I row and j plus 1 column is equal to I row, j row plus 1. So this means it's equal to the previous value plus 1. After this loop is done, we check the sum. Basically, we check that the sum of Sm, if it's equal to Sv. If it's equal, we break the loop, we stop the loop. The second loop here, if this is not equal, the loop continues. So the second, as I said, go from top to bottom. In this case, is the column that is fixed, because we are working on, in this case, we are working on this column. And what is moving is the number of rows. And again, basically, we are saying that given that this column is fixed, the following row is equal to the value of the previous row plus 1. When this is finished, we check again the sum, and if Sm is less than Sv, the loop continues. So here we have in the third loop from right to left, in this case we would be here. And again, in this case, as you can see, the row is fixed, is y underscore n, and initially this value, this one, number of row of m. In this case, if the matrix in this case is 7 by 7, this means that n is equal to 7. Okay, and what we are moving is the number of columns. In this case, it's j minus 1 because in this order is reversed. So j minus 1 is equal to the previous. In this case, in the previous is the number to the right. But again, this will be clear when we break down the function. After the third loop is done, we check the sum. If Sm is less than Sv, we continue. And this is the for loop. So from bottom to top, in this case, it's the column to be fixed, j start. So this is 1. And what we are moving is the number here of rows. Again, after this is done, we check the sum, and if Sm is less than Sv, we continue. In this case, we update these values here. Why we update this value? Because let's go to this level here. As you can see, this is the third loop. We're going from 15 to 21. Then this is the fourth loop, 26, and then that's like this, and then again, this is the third loop. This time, we're going from 35, and we're stopping here to 39. So we're stopping one column before. And what we are doing basically here, we are controlling for these numbers when we have to stop, basically. So in this case, we stop one column before, and if we continue, in this case, we go up, we stop one row before, because as you see, we don't overwrite 27. We stop here. And if we continue, as you can see, again, this is again the third loop, we stop here. So we're stopping one column before again. After updating this value, the loop starts again here from the first loop, then second loop, third loop, until this condition Sm equal Sv is satisfied. When this condition is satisfied, the loop stops and this M object, this matrix filled with all the values, is returned. So now, let's check again. But let me run the function again. Okay. You can see I run this function again. And let's check these examples here. So we have a 8 by 8 and we're starting from 5. Now, as you can see, 5, we're going here from left to right, 12, from top to bottom, 19, from right to left, 26, from bottom to top, 32. And then again, from left to right, but now not that the right stop here. So we reduce the number of columns. The second loop here starts from 38 and stop here, 33. So we reduce the number of rows. And again here from 43, 48, and then here 52, 56, 59, 62, 64, 66, and then up to 68. Again, why 68? Because again, if we starting from 1, the maximum value would be 64. But we're starting from 5, so we're moving 4 units to the right. So 64, 65, 66, 67, 68. Okay, let's see another case here. And as you can see now, we have an error. And this is the message that we wrote before. Why? Because this is not a square matrix. We have 7 rows and 8 columns. Let's see another example here. As I said, we can start also from a negative number. We're starting from -1. And now we are moving 2 units to the left. So again, if we're starting from 1, the maximum value would be 64, but we are starting 2 units from the left, as you can see, 2 units from the left from 1, so the maximum value here is 62. Let's see another example now. The 10 by 10, we start from 1, so the maximum value is 100. We're doing like this up to 100. If we start from 0, we are moving 1 unit to the left, so the maximum value is 99. Another example, 10 by 10, we start from -50, and you see from -50, we go to 49. Okay, last example, 4 by 4. Starting from -8, so we go -8, -5, -2, 1, 3, 5, 6, 7. Now, we are going to break down the function and we are going to replicate step by step this last case. So let's start. What I mean by breaking down the function. Basically, I'm taking all the code inside the body of the function and I'm taking out and I am implementing manually. So let's start here. We need to generate the M matrix, and this is a 4 by 4 with all zeros. Now, note something. In our environment, we don't have the IV object. If, for example, here, I try to implement this code here, we get an error, IV not found, because IV now exists only in the body of the function. What we have to do in this case, we have to set the IV manually. So I generate now IV, and because we are replicating this example here, IV is equal to -8. Now we set the IV equal to row 1, column 1. You can see now we are here. This is the initial values -8. Again, also this I star, J star, and so on, they don't exist in our environment here because they exist only in the body of the function. So we need to set this manually. And here, okay. Now the condition to fulfill the loop. Okay, as I said, if we start from 1, we know that, for example, here, the maximum value will be 16. And if IV is 1, IV 1 minus 1 is 0, so this is 0, so the maximum value is 16. But in this case, we are starting from -8. So if we run this is -9, so 16 plus -9, we get 7. So 7 is the largest number in the sequence that goes from IV to S max. So if we run this sequence, let's select IV colon S max, we see that we go from -8 to 7. So this 7 is the largest number. Now, we know also the sum of all these numbers, but now we have to use the absolute value. Why? Because this is a special case, and that's why I chose this matrix with this initial value here. Because if we don't use the absolute value and we sum this sequence here, what happens is that these numbers, they will be cancelled out by these numbers. Basically, this sum is 0. And what happens is that the sum of SV will be -8. But -8 is also our initial value. So this means that SV and SM would be equal. In this case, the loop does not start because, again, let me go back. The condition here for the while loop to start is that SM is less than SV. But in this case, SM would be equal to SV. That would not allow the loops to start. That's why we're going to use the absolute value. You can see now the sequence is all positive numbers, and when we sum here, we get this is 64. And now we sum the absolute value of the entries in the M matrix, and now this means that the value is 8. And since 8 is less than 64, we are inside the while loop. Now, because we are breaking down, we are checking that condition manually. So, as you can see, I didn't include the while loop here. So let's start. We are inside now. We are inside the while loop. Let's start to check this for loop. So for j in start, colon, and -1, this is the sequence basically. Let's see the numbers. For j in 1, 2, and 3, I have this check here, but I will explain when we run the first loop for the second time. This code is implemented. So as you can see, I start is fixed. So now I start is 1. So this means that we're working on the first row. As you can see, this one here. We are working here. What changes is the number of column, the number of J. So J, we say that J is 1. So this means that J1 plus 1 is 2. So we are here. So we are saying that this value is equal to M1 and J is 1. So we are saying that this value is equal to this value that is given by this plus 1. So this means minus 8 plus 1 minus 7. Then the loop starts again and J becomes 2. So this means that here J is 2. This value indicates the column is 2 plus 1. So this means that we are here. The row is always fixed. The column is moved to 3. We're saying that this value here is equal to the sum of the previous value plus 1. But now the previous value is minus 7 plus 1 is minus 6. So let's run. As you can see, minus 7, minus 6, and this is the last one, minus 5. When j is 3, this is j, 3 plus 1 is 4. So we're saying that this value is equal to I star is 1, j is 3. So 1, 3 is equal to these values plus 1. And then we implement the check. SV is always the same, and it's 64. Now SM is 26. Still less, so the loop continues. We are now in the second loop here, so we move from top to bottom. And in this case, it's J to be fixed. So J is fixed to 4. So we are working on this column. What is moving is the number of rows. And now the sequence is this one. So I is 1, 2, and 3. So at the beginning, I is 1. So 1 plus 1 is 2. So we're saying the matrix element 2, 4. 2, 4, this one. We're saying that 2, 4 is equal to the sum of I is 1, I 4. I 4 in this case is 1. So 1, 4 is minus 5. Minus 5 plus 1 equals minus 4. And this is continuous until we fill this value here. So let's run the code. As you can see, minus 4, minus 3, minus 2. Again, we check the sum. And as you can see, we're approaching 64, but still less. So it's the time of the third loop from right to left. So we are here. In this case, again, we are fixing the row. And now the row is I end. I end, in this case, 4. Remember, we set I end here, the number of row of the matrix. And this does the same thing. But the order here, for example, in this case, because we are going from right to left, I reverse the order. You can see this is 4, 3, and 2. And consequently, I change here. We are moving the column, but I'm considering j minus 1, that is equal to I and j, and we're always add 1 unit. So when we run this, minus 2, we are adding 1 unit, minus 1, we are adding 1 unit, 0, 0, we are adding 1 unit, 1. We check. Again, we are approaching 64, but still far. So, time of the for loop. The for loop goes from bottom to top. Again, here the column is fixed, they start, and is 1, and we're moving the number of rows I, and the sequence for I is this one. 3 and 2. As you can see now, we are saying and -1. Why? Because we don't want to overwrite this. So we are reducing the number of rows, and we are stopping here. So when we run this code here, you can see we add 1 unit, so 1 plus 1, 2, 2 plus 1, 3, and we stopped here. Check again the sum. As you can see, we are still below 64. So the loop needs to continue, but what we have to do is that we have to update these values here, because we have to control for the number of rows, number of columns. For example, now, when we start from here, we need to stop here and not anymore to 4. So we need to stop to 3 and not to 4. So we need to update these values here. And then we have to start again from 1. So this is the first loop here. Now, let me explain why I set this one. The issue is that when we started the first loop, as you can see, we considered this value here. This was 0. So we say that row 1, column 2 is equal to row 1, column 1 minus 8 plus 1. But now, what changed here is this row, because now we updated this value. So this means that I star here is not 1 anymore, but now 2. So we are here. But the value here, we need again to start from column 2. So I did not change the initial value of this sequence, but what I did is to check that the initial value is 0. So if this value is 0, this is implemented. So if I star, comma, j plus 1 equal to 0, this is implemented. Otherwise, the loop moves 1 unit forward and check again this. And if it's 0, implement this code here. So let's run. And as you can see, we were at 3, 3 plus 1, 4, 4 plus 1, 5, and we stop. We check the sum. We are 51, so still margin. So it's the time of second loop. So from top to bottom, as you can see now, we have just 1 unit left. And if we check here this sequence is just one number. In this case is 2. 2 plus 1 is 3. And this is row number 3. And in this case, the column is fixed. And after updating the value, j end is 3. So we are working on this value here. When we run, we get only 6. We check the sum. And as you can see now, it's 7. And the only value missed in this one is this 7. 6, 7. And this is the difference here. So when we run the third loop for the second time, as you can see, we just filled the missing value 7. Now, when we check sum, we have that Sm is equal to Sv. So Sm is not less than Sv anymore, so the while loop stops. After stopping the while loop, we return the value here of the matrix. And the matrix is this one because we finished to fill up all the values. So I hope this is clear.